Hi, I'm Fathom. This video series will be documenting my efforts at developing a high-level object-oriented programming language in C. The format of these videos will be in the form of a time-lapse with very minimal commentary. It should be noted that this is not a tutorial series. I will not be explaining in any sufficient detail the specifics of the code I am writing. However, I will be explaining the overall role that the components I am writing play in building a functional interpreter. Also, a disclaimer, I am not a professional developer, nor do I have any higher education in computer science. This is a hobby project, and everything that I am writing is purely for fun. That being said, little planning or preparation has gone into it. Just about all the work I'll be doing will be recorded and present in the series. Since I'm not planning any of this ahead of time, you'll see me debugging and restructuring my code as issues arise or as I decide to change my approach to a given task. The language I'll be writing is roughly based on a concept I had years ago. The syntax will resemble C, with braces and semicolons. However, the language's runtime and standard library will be modeled after C Pythons. With all that out of the way, let's get started with the first part, writing a functional lexer. Alright, so one of the very first things I'm going to do here is I'm going to create the directory structure for the project, and I'm also going to create a plain makefile. The reason I'm handwriting a makefile is to keep this project minimal and avoid any dependencies on any third-party build systems like CMake or GNU Auto Tools. Alright, so one of the very first things I'm going to write here is a linked list implementation. Now this is going to be very important once I start working on the actual interpreter itself. As you can imagine, a lot of the components of the interpreter, such as the lexer and the parser, are going to have lists of various elements.
Feeling never stop. You can hide in the dark, the sun will rise sometime. Blind, home and bar, no difference, but I know.
Alright, now that I have a linked list implementation, I'm going to go ahead and I'm going to implement a hash map style dictionary. So this isn't actually something that I'm going to need for a while, but I figured I'd implement it right now, just that way I don't have to worry about it later on.
Here's the truth. So now you can hate me. I don't love you anymore. Goodbye. Twice I turned my back on you. I fell flat on my face, but didn't lose. Tell me where would I go?
With that out of the way, there's just one more thing that I need to implement real quick before I begin working on the lexer. In order to tokenize source code, I'm going to need a way to build strings dynamically at runtime. To do this, I'm going to write several functions that will allow me to dynamically build a string on the heap.
There's no way out, the only way out is to give in. When there's no way out, the only way out is to give in. How I love to, how I love to, how I love to give in.
Alright, with all that out of the way, it's time to start working on the interpreter itself. The first component I'm going to write is the lexer, which is going to be responsible for converting the source code into a list of tokens that can be fed into a parser.
Where no one sleeps, one lays up by the other lies down. Ask the line on your face, what the line on your hand meant. We couldn't see what was coming.
As you can see in the output in my middle right terminal window, the lexer is successfully producing a list of tokens from a given input string. All that needs to be done now is the addition of a few other token types and the lexer will be complete. Alright, so I think I've developed a sufficient enough lexer to tokenize basic programs. I think I'm going to call it quits here. In the next video, I'll be parsing the output from the lexer to generate an abstract syntax tree. If you like this content, please subscribe. I'll be releasing these videos on a weekly basis and additional content as this project progresses.